In question 2.6, for a particle in a one-dimensional box of length L, we're asked to consider an infinitesimal interval of length dl that lies within the box, let's say from 0 to L. For each of the following stationary states, state which location or locations of this interval gives a maximum probability and which gives a minimum probability to find the particle in the interval. And we are asked to look at three different states, n equals 1, 2, and 3. So let's first write down the wave function psi, which is equal to 2 L under root sine okay. Now, if you want to compute the probability, you need to compute this, right? So we care about the probability density here. Let's first compute that. That will be 2 over L times sine squared and pi x over L. Now, we need to find out when this value is going to be maximum and when this value is going to be minimum, right? For what values of x gives you a maximum value and what values of x give you a minimum value. Now, for A, psi squared is going to be 2 over L times sine squared pi x over L. Now for n is equal to 2, it's going to be 2 over L times sine squared 2 pi x over L. Now for n is equal to 3, it's going to be 2 over L times sine squared 3 pi x over L. So if you want to have a minimum value, right, that would be when the probability is 0. That's the minimum value. The minimum value is determined by the sine function because 2 and L are basically constants. So the minimum value of psi squared is going to be the minimum value sine squared function can take. And the maximum value of sine squared is going to be the maximum value the sine squared function can take. So this is something we need to remember. So sine, as we know, let's say if this is 0, sine 0 is 0. Sine is an oscillating function and it basically repeats itself after an interval of 2 pi. Right? It tends to repeat itself. So I'm just going to erase this. And we know that, maybe I shouldn't have erased it. When you have a sine function where this is 0 and this is pi over 2 and this is pi and this is 3 pi over 2 and this is 2 pi and so on, we know that the minimum of a sine function or a sine squared function is going to be when x is equal to 0, right? If you were to look at sine of x when x is equal to 0 or when x is equal to, let's say, n pi. If n is confusing, maybe we can just call it x is equal to n pi. For any value, n could be 0, 1, 2, it could be anything. So for multiples of pi, if you have sine of x, when x is a multiple of pi, you're going to have sine of x to be equal to 0. So that's the minimum value a sine squared function can take. And the maximum value a sine squared function can take would be 1, right? So this value here is 1, and this value here is minus 1. So sine of pi by 2 is 1. sine of 3 pi by 2 is -1. However, when you square these values, sine square of pi by 2 is the same as sine squared of 3 pi over 2. The sine value itself differs by a sign, but the square of the sine value is actually the same for both. So if you want to have a maximum value of sine squared function, that's going to be 1. And if you have sine squared y is equal to 1, that would mean y is equal to n pi over 3. And n can be 1, 2, 3, n could be pi over 3, 2 pi over 3. Sorry, it's not 2 pi, no. It could be an odd number, n is an odd number, 1, 3, 5, and so on. It could be pi over 3. I'm sorry, this is not pi over 3. No, this is a typo. Let's say n pi over 2. So m can be an odd number, 1, 3, 5, and so on. So you can have sine of pi over 2, sine of 3 pi over 2, sine of 5 pi over 2, and so on, right? So for all of these values, sine squared of the value is going to be 1. So that's the maximum value we can have. So let me just do this. So for n is equal to 1, we need to worry about this, right? So the maximum value it can take is equal to 1. That implies pi x over L is going to be n pi over 2, and n can be 1, 3, 5, and so on. Now I am going to go ahead and cancel the pi there. That would give me x to be equal to ml over 2, and n can be 1, 3, 5, and so on. We know that x has to lie between 0 and L. That's our constraint because that's the length of the box, and the wave function is 0 everywhere else because you're dealing with a particle in the box where the potential is infinite everywhere outside box of length L. So the wave function is 0 outside the box and at the boundaries of the box, and the wave function is only finite. It has to be finite at some point in the box. So this is the constraint we have on x. So plugging in these values, we see that x is equal to L by 2 or 3L by 2 or 5L by 2 and so on, right? However, 3L by 2 and 5L by 2, those are not possible values, right? That's because 3L by 2 is nothing but 1.5 times L. 5L by 2 is 2.5 times L. So you're moving out of the box. So these values are not possible. So the only value that's possible is x is equal to L by 2. So at the center of the box, you have maximum probability of finding your particle. Now, the minimum value you can see is 0, right? Now that would mean this term pi x over L is going to be n pi from here, right? And n can be 0, 1, 2, and so on. So I am going to cancel out pi here. And that would give me x to be equal to nl. And we again have the constraint that x be between 0 and L, or we also know that the wave function is 0 at 0 and at L, at the boundaries, right? So this would imply x can be, when m is 0, it's going to be 0. When m is 1, it's going to be L. When m is 2, it's going to be 2L and so on. But we are not going to consider those values because they fall outside the box. So x is equal to 0 and L are the values at which we observe minimum of, we observe minimum probability density of finding the particle inside the box. That's for part A. Now, for part B, where n is equal to 2, right? When n is equal to 2, the wave function is going to be we know n is 2, so I'm going to write 2 pi x over. Right, again, so the maximum value is going to be 1, and that implies 2 pi x over L is going to be n pi over 2, where n is an odd number, 1, 3, 5, 7, and so on. Right, now canceling out pi on either side, x will be nl over 4. And we have our constraints that x be between 0 and l. So x can be L over 4, 3L over 4, 5L over 4, and so on and so on. However, these values are not possible because 5L over 4 is 1.25 times L. So everything that's starting from this value is going to be outside your box. So they're not possible. So x equals L by 4 and 3L over 4 are the values inside the box at which you're going to find maximum probability of finding the particle inside the box. Now, the minimum value you can observe is 0, right? That implies 2 pi x over L is going to be n pi. I'm going to cancel out pi again. That would give me x to be ml over 2. And we again have the constraint that x has to be within these limits. So x can be, when n is 0, it's going to be 0. With 1, it's going to be L by 2. With 2, it's going to be 2L by 2, which is nothing but just L. So I'm going to remove that. And then we're going to have 3L over 2, 2L, and so on. Now, all these values are invalid because they're outside the box. And so the values of x at which you're going to observe minimum probability or 0 probability are x equals 0, L, and L by 2. And if you remember, L by 2 is the node. L by 2 is the position at the center of the box. You have a node when n is equal to 2. Now, moving on to part C, where n is equal to 3, the wave function, the probability density is going to be 3 pi x over L here. The maximum value is going to be 1. That implies 3 pi x over L is going to be n pi over 2, with n being an odd number. Now, I am going to cancel out the pi. It can be L over 6, 3L over 6, which is equal to L over 2, 5L over 6, 7L over 6, and so on. And everything from 7L over 6 is invalid because it extends beyond the length of the box, right? And this one is nothing but L over 2. So the valid values of x are going to be L over 6, L over 2, and 5L over 6. So at these values of x, you're going to find the maximum probability of finding a particle. Now the minimum value is 0, so I'm going to cancel out 5. And over 3 X can be 0 when n equals 1, you have L over 3, then 2L over 3, 3L over 3, which is nothing but just L, 4L over 3, and so on. Everything from 4L over 3 is invalid because it's outside the box. So at X equals 0, L over 3, 2L over 3, and L, you're going to see the minimum probability of finding the particle, where the wave function is 0, you don't actually find the particle. So this and this, so these two are the nodes. They're in the middle of the box at L over 3 and 2L over